Alright, last unit of the year, Unit 12, Surface Area and Volume. A polyhedron is a solid that is bounded by polygons. These polygons are called faces, okay? And all the faces of a polyhedron enclose a certain region of space. An edge of a polyhedron is a line segment formed by the intersection of two faces. So you see where this face and this face intersect, they intersect at an edge. A vertex of a polyhedron is a point where three or more edges meet. Okay? So, Euler's theorem, this is pronounced Euler's, states that the faces plus the vertices equals the edges plus 2. So, however many faces a polyhedron has, plus however many vertices it has, will always equal the edges, the number of edges, plus 2. Okay? Convex and concave, you guys hopefully remember this when we were learning about polygons. If all the vertices are pointing out, it's convex. If it caves in somewhere, it's concave. Alright. A prism is a polyhedron with two congruent faces, called bases. Okay? The bases lie in parallel planes, and the other faces, called lateral faces, are parallelograms formed by connecting the corresponding vertices of the bases. The segments connecting these vertices are lateral edges. Prisms are classified by the shapes of their bases. So this one would be a rectangular prism. If I had a triangle for a base, it would be a triangular prism. A cylinder is pretty much the same thing as a prism, except it has a circle for each of its bases. Okay? The surface area of a polyhedron is the sum of the areas of its faces. The lateral area of a polyhedron is the sum of the areas of its lateral faces. Alright? If you have a right prism or a right cylinder, what that means is that each lateral edge is perpendicular to both bases, or in the case of a right cylinder, the segment joining the centers of the bases is perpendicular to the bases. Okay? An oblique cylinder, or prism, is a prism with lateral edges that are not perpendicular to the bases, kind of like the one shown here. In any case, the equation to find the surface area would be 2 times the area of the base plus the perimeter of the base times the height. Okay? A pyramid is a polyhedron in which the base is a polygon and the lateral faces are triangles with a common vertex, called, and I labeled it here, vertex. Okay? The intersection of two lateral faces is a lateral edge, just like in the case of a prism. Okay? And the triangles are lateral faces, just like how the parallelograms are lateral faces for a prism. Okay? The height of a pyramid is the perpendicular distance between the vertex and the base. A regular pyramid has a regular polygon for the base. Remember, regular means equilateral and equiangular. And the segment joining the vertex, actually let me label. So in this case, it's a square pyramid, meaning the base is a square. Okay? The lateral faces of a regular pyramid are congruent isosceles triangles, and the slant height of a regular pyramid is the height of a lateral face of a regular pyramid. Okay? A non-regular pyramid does not have a slant height. I labeled the slant height L over here. Okay? Pretty much all the same things apply to a cone. It's basically just like a pyramid, except it has a circular base. It still has a vertex, a right cone. This is not a right cone, but if it was a right cone, the segment joining the vertex and the center of the base would be perpendicular to the base. And the slant height, you know what, I messed up here, sorry guys. it only has a slant height if it's regular. Okay, so in this case there would not be a slant height. So, if you're trying to find the surface area of a cone or a pyramid, it's going to be the area of the base plus 1/2 the perimeter times the slant height. Okay, here are the formulas for the volumes of each of these. Make sure you guys don't confuse the height with the slant height. Remember, the slant height is slanted, the regular height is perpendicular to the bases. Okay? A sphere is the set of all points in a space equidistant from a given point. Remember, equidistant means equal distance. The point in the middle is called the center. A radius of a sphere is kind of like the radius of a circle. It's the segment from the center to a point on the sphere. A chord, kind of like a chord of a circle, is a segment whose endpoints are on the sphere, and a diameter is a chord that contains the center. Okay? And here are the formulas for the surface area and the volume. The volume congruence postulate, this should say congruence, sorry about that, states that if two polyhedra are congruent, then they have the same volume. Okay? The volume addition postulate is a lot like the segment addition postulate, the angle addition postulate, all the addition postulates we've learned. The volume of a solid is the sum of the volumes of all its non-overlapping parts. So if you have something that looks like this, the total volume of the solid would be the volume of the pyramid plus the volume of the cube. And that, if you add those two together, you get the total volume. And finally, the similar solids theorem. If two figures have a scale factor of a to b, then their perimeters also have a ratio of a to b. Their areas, or surface areas, have a ratio of a squared to b squared, and their volumes have a ratio of a cubed to b cubed. And we will do some examples of these in class. And that's it.